Okay, so this is the second video on circular motion dealing with angular speed and linear speed, okay? Just to kind of revisit the formulas. Angular speed, omega is this symbol right here. Omega is going to be the angle in radians, we call theta, divided by time, okay? So the unit is always going to be radians per whatever unit of time we're dealing with, all right? Linear speed is going to be this v velocity here is the arc length, okay? S stands for arc length here, which can be found multiplying the radius of the circle times theta divided by unit time, okay? So arc length is going to be a unit of distance, so inches, centimeters, feet, miles, etc., divided by a unit of time, seconds, minutes, hours, etc., okay? So let's go on down to example 2. We did example 1 in the previous video. All right, so in example 2, we've got a circular blade, okay, so that's where the circular motion comes in. On a saw here has a diameter of 9 inches. Okay, remember that's diameter. We need the radius eventually, so we're going to have to cut that in half. And this saw rotates when it's going full speed here at 4,500 revolutions per minute. Okay, so here we're given a unit in terms of minutes for time, but in both of the problems down here we're asking for seconds. All right, so we're going to have to use this conversion factor, 1 minute equals 60 seconds eventually. Okay, in both problems. All right, so find the angular speed. Well, first off, I need to know what the angle is. All right, so in 60 seconds, the angle changes 4,500 times 2 pi radians. All right, the reason that's the case, it makes 4,500 revolutions per 1 minute. Okay, and 1 minute is 60 seconds. Okay, so because this saw is making 4,500 revolutions every 60 seconds, we're going to multiply 4,500 times 2 pi, okay? And that's going to give me 9,000 pi radians is the angle that we're going to be dealing with here, okay? So find the angular speed. Well, omega equals theta divided by time. We've got 9,000 pi radians that occurs every 60 seconds. So I'm going to divide those two values, 9,000 pi over 60 seconds. And when I simplify, I should get 150 pi radians per second for omega, okay? So that's how fast the angle is changing every second, okay? Convert that to decimal form, just so you know how to do that. Multiply 150 times pi, and you get 471.24 radians per second, okay? Again, this is an exact answer in terms of pi. This is an approximate answer raised or found to the nearest hundredth, okay? The linear speed of the saw. Now, here we want feet per second. So we got to be aware we were given the diameter in inches. So at any point within this problem, you can make the conversion from inches to feet, okay? I'm going to show you when I do that. You can make the choice of when you want to make that conversion, okay? So obviously we need the arc length because it's part of our formula. And arc length is going to be the radius, which is going to be half of my 9-inch diameter here. Times theta. And again, theta is going to be the angle 9,000 pi radians. So find the arc length. We've got 4.5 inches, okay, which is the diameter. And again, you could have already converted this to feet if you want to. I'm going to do that a little bit later, but you could do it here in the first step if you'd like. But the arc length is going to be 4.5 times 9,000 pi, which is 40,500 pi inches, okay? Now's when I'm going to make the conversion. I think it's a little bit easier to do it here. So we want to convert inches to feet. So the conversion factor is 1 foot for every 12 inches, okay? I need inches to cancel out, so that's why I'm multiplying by 1 foot per 12 inches and not the reciprocal of that, 12 inches per 1 foot, okay? In this case, you'll see the inches cancel out, and I'm left with the unit of feet, which is what I want, okay? So that means I'm going to be dividing 40,500 pi by 12, which gives me 3,375 pi feet for the arc length, okay? So this is the value that's going to go into my linear speed formula in just a second, okay? So formula speed is, the linear speed here is going to be the arc length divided by time. Plug in what I know, okay? So again, we're dealing with a time of 60 seconds. I want my unit to be in feet per second, so I've got everything just like I need it here. So let's divide these two values. That gives me 56.25 pi feet per second. Okay, so that's the linear speed of this saw when it's traveling 4,500 revolutions per minute. Okay, an approximate answer then, just plugging that into a calculator, would be approximately 176.71 feet per second. Okay, so that's how you find angular speed and linear speed.